Welcome to a fascinating journey into the heart of quantum computing, a field that's revolutionizing technology. Here, we'll demystify the fundamental building blocks, the classical bits from traditional computing, and the innovative qubits that make quantum computing possible. First, let's understand the classical bit, which serves as the absolute foundation of all traditional computers we rely on daily. To make it simple, imagine a basic light switch right on your wall at home. This everyday switch can only be in one of two distinct states, either fully on, representing a binary 1, or completely off, representing a 0. Importantly, there's absolutely no in-between position. It's strictly binary. This reliable binary system of zeros and ones is precisely how classical computers store and process every kind of information, from simple text documents and emails to incredibly complex mathematical calculations and simulations. Now, let's boldly step into the extraordinary quantum realm and meet the qubit, which is the quantum equivalent of a classical bit, but with mind-blowing capabilities. Unlike a straightforward light switch with just two positions, think of a qubit more like a versatile dimmer switch that you can adjust smoothly. It's definitely not limited to just fully on or fully off. A qubit can exist as 0, as 1, or, and this is the truly mind-bending part, a superposition where it's a combination of both 0 and 1 simultaneously until measured. This remarkable and incredible ability of a qubit to exist in multiple states at the exact same time is what physicists call superposition, a core principle of quantum mechanics. To visualize it better, imagine a coin spinning rapidly in the air during a coin toss. While it's spinning so fast, it's neither definitively heads nor tails, but rather a probabilistic combination of both possibilities. This spinning coin analogy perfectly captures how a qubit behaves in superposition, holding the potential for both 0 and 1 outcomes until it's observed or measured. And while a qubit is in this superposition state, it can hold vastly significantly more information than a single classical bit ever could, enabling exponential computational power. However, there's an important catch to this quantum magic. The precise moment you measure or observe a qubit, its delicate superposition instantly collapses. Just like our spinning coin must eventually land flat on a surface and reveal either heads or tails definitively, a qubit collapses into a single, definite state of either 0 or 1. This fundamental property means we can't directly observe or witness the superposition in action. We only ever see the final outcome after its collapse during measurement. So, why exactly does this quantum behavior matter so much in practical terms? Why is this ability to occupy multiple states simultaneously such a powerful feature? The key reason is that qubits, by existing in multiple states at once through superposition, allow quantum computers to process and evaluate a vast number of possibilities all simultaneously. This unique parallel processing capability renders quantum computers incredibly powerful for tackling complex problems that would be practically impossible or take eons for classical computers to solve. Think of it in everyday terms like this. A classical computer approaches problem solving by trying each potential solution one by one, much like searching a huge maze by testing every single path sequentially, step by step. In contrast, a quantum computer, leveraging its qubits in superposition, can explore and evaluate all possible paths through that same maze at the very same time, dramatically speeding things up. This exponential surge in processing power promises groundbreaking breakthroughs across fields like medicine for drug discovery, materials science for new substances, cryptography for secure communications, and even artificial intelligence for smarter systems. In summary, a classical bit is fundamentally like a simple, reliable light switch that is either on or off, straightforwardly representing a 0 or a 1 in binary form. This definite, strictly binary state forms the unshakable bedrock of all our current digital technology, from smartphones to supercomputers. A quantum qubit, however, is far more dynamic, akin to a dimmer switch adjustable to any level or a spinning coin in motion, capable of being 0, one, or both simultaneously thanks to superposition. This distinctive quantum property fundamentally enables an entirely new paradigm of computing, one that unlocks immense and transformative potential for the future. While classical bits remain the solid foundation of today's vast digital world, qubits are actively paving the way for tomorrow's quantum revolution in computation. Ultimately, the future of computing isn't merely about achieving faster calculations with more power, but about tackling and solving problems that were previously deemed utterly unsolvable by any classical means. Thank you so much for joining us on this enlightening exploration of bits and qubits. The exciting quantum age is truly just beginning, and the possibilities are endless.